Hello and welcome to today's demonstration. Today we're going to be looking at the problem of fraud, and particularly we're going to be looking at what types of applications we can build on top of a Neo4j graph database for detecting and investigating fraud. For our agenda today, we'll start by looking at the problem of fraud and why graphs are a particularly good way to store and organize our data to help us prevent and investigate fraud. Then we'll jump in and look at three particular types of patterns in that data that we can detect rapidly using a graph database. Things like fraud rings, shared PII, and transfers of money to high-risk jurisdictions. We'll take a look at how graph databases can help us solve these particular suspicious problems.
Now, as background, I think we can all agree that fraud is a big and growing problem. There's no question that the scams that are being perpetrated out there are costing businesses real money, and it's costing us more and more money year over year. So why do graph databases particularly help us detect and prevent fraud? Well, today we're going to be looking at particularly how graphs can expose patterns that are hard to find using other technologies and how it can do that quickly, in some cases thousands of times faster than traditional solutions. So in our demonstration today, we're going to be using a fairly straightforward model, and I'd like to focus particularly on the top part of this model in our graph. So we have customers at a bank, and those customers can have accounts. So you can see customers and accounts, and those accounts can be used to transfer money to other accounts. Some of those accounts might be inside the bank, some of them might be outside the bank. And you can see we also have information about our customers, their phone numbers, emails, and their physical addresses. So we're going to be using this model in our demonstration today to have a look at how we can detect and prevent fraud. So let's jump right into that demonstration. So we will start by looking at a dashboard here. And in this dashboard, we've got the three patterns we said we would talk about. So let's start with transaction rings. So what are transaction rings? Transaction rings are things we see in money laundering where somebody receives some money and then they use other accounts to hide the source of that money. So they transfer some of that money to another account, who then transfers some money to another account, and eventually makes it back to the originator of the ring. And you can see here we built a very simple dashboard where we've exposed some rings up on the top where we have the account number and the ring size. And then down on the bottom, we can investigate and see those rings. So just to show you the results here we can see a ring and we can explore the transactions and we can look at the accounts and explore them in the dashboard. Let's look at the query behind this and look at how simple this is compared to what we might have to do in a traditional solution. So here what we're doing is we're matching a pattern, and the pattern that we're matching is simply an account sending some money to another account. So we can see an account originates a transaction, we have a relationship sent, and there's the first transaction that kicks off this ring. And then we have a pattern which we call a quantified path pattern, where we look at how that money is then transferred to another account and eventually makes it back to the original account A. So you can see we start with A and we end with A. And then there's some things that we're checking in between. So we're first of all checking the dates to make sure that the ring is sequential in terms of time. So we look for a transaction followed by a transaction followed by a transaction, not just constructing rings willy-nilly out of dates. And then we're also looking at the amounts of those transactions to where a typical money laundering ring, each account in the ring is retaining some portion of that money as their fee for laundering the money. So yeah, it's kind of funny to think of it as a fee, but criminals are charging a fee to launder money. And so what we're looking at here, and ultimately, we're looking for 2 to 15 steps. So we're looking for rings that comprise 3 to 16 transactions. We've got the first transaction followed by 2 to 15 more. And then finally, we have a little bit of code here at the end to make sure that we're not seeing duplicates. So what we see here is really a very simple, straightforward query, 11 lines. I've actually written this code in SQL, or actually, let me say I started to write this code in SQL using a relational model, and I got up to ring sizes of about 4 or 5, and I was well over 100 lines of code. And then at that point I stopped. I said, I'm going to be writing hundreds of lines of code. So ultimately, what are we seeing here with a graph database? We're seeing that a very simple, easy to write, easy to understand, and highly performant query. You can see how fast these queries are running in a graph database that can help us detect suspicious patterns, such as transaction rings. Now let's move on to the second pattern, looking for shared identifiers. What are shared identifiers? Shared identifiers are a potentially suspicious occurrence where we see multiple customers that are sharing some piece of PII. So maybe they're sharing an email address, or sharing a phone number, or sharing a physical address, or sharing, multiples of these kinds of things. And these patterns can be suspicious. They can be legitimate, but they can also be suspicious because fraudsters will create multiple accounts using the same email address, or using the same phone number, or maybe connecting from the same IP address. You could see how there's lots of different ways that fraudsters can try to hide their activity. But ultimately, what we're trying to do is to find commonality between customers that have been set up. So here, again, similar to our fraud ring query, we have lists of occurrences on the top, and then we have some details on the bottom. So here we could see that there are 5 customers sharing an address. Here there are 5 customers sharing a phone number. And just as before, we can use the dashboard to browse and understand the data. But looking at the query here, again, graph databases help us find this shared information in a really simple and straightforward kind of a query that, as you can see, performs very, very quickly. And let's have a look at our query. What we're looking for are, we have a customer at the beginning here and a customer at the end. So we're looking for 2 different customers. And right here, this where clause is going to make sure that we see different customers. And then we're looking for any kind of a relationship that shares, in this case, a phone number, an email, or an address. The thing I'd like to highlight here with this query is that if you compare this to a relational model, you would typically be using multiple joins to try to figure out this kind of scenario where we're sharing PII. Graph databases don't need joins. We can do this very, very quickly by just traversing relationships in memory. And so what we have here is a very, very simple query that helps us find any kind of shared PII very quickly and easily, enables us to investigate that. So finally, let's look at the final pattern, what I'm calling high-risk jurisdictions. And an easy way to explain this is just to focus on the concept of a high-risk jurisdiction. There are some places where if we see a customer sending some money there, and I'm not going to mention countries here, but there are some countries around the world where if a bank sees a transfer to that jurisdiction, that they need to investigate that further. So what we want to do is, first of all, to find those transactions that are going to what we call a high-risk jurisdiction and investigate where that money potentially came from. So not just looking at that individual transfer there, but who transferred money into the account that is then pushing money into high-risk jurisdictions. So for example, let's take a look at this one in the center here. We have an account here ending in 129 that's sending money to high-risk jurisdictions. If we look at the details of the graph here, well, we can see 2 transactions that are going off to high-risk jurisdictions. And just like we did before, we can investigate the details of those transactions or those accounts. And we can see how money was sent into that account from another account. So we get a very a broad picture, not just the instant transaction we're concerned with, but we can look at the background behind that transaction and where that money potentially came from. So let's look at this query, because to do this kind of thing when data is stored in rows and columns, it's going to be a pretty complicated query that probably doesn't perform particularly well. But looking at a query in graph, and we're going to anchor on a particular date here. So I just picked this one at random. And we look for a starting point where the account is transferring money to a high-risk jurisdiction. That's the easy part. Now, the fun part comes when we start to look at the details. Where did this money come from? So we're going to sum up all of those transactions to the high-risk jurisdiction, and then now start to look prior in time You can see we're doing a date filter down here, and we're looking for things that are roughly close to the amount that was sent to the high-risk jurisdictions. So this query, what it's doing is it's looking back in time to find all the money that has come into the account that is then engaging in this suspicious activity. And we're doing some filtering down here to make sure that we're not identifying duplicates. So very, very concisely, we're able to look for the kinds of patterns of transactions that are suspicious in this case, or things that we need to investigate and potentially report back to the authorities, to government monitoring agencies. So what have we looked at? Just really briefly, we looked at the problem of fraud. We looked at broadly how graph databases can help us build applications to detect and investigate fraud. And then finally, we looked at three patterns. We looked at a money laundering pattern of transaction rings. We looked at, kind of hidden or fake account types of patterns where people are creating accounts with shared PII. And then finally, we looked at a transaction monitoring scenario where we're looking for transactions to high-risk jurisdictions and then investigating where that money has come from. So if this has been interesting to you, what you can do next, you can head on over to neo4j.com/usecases/fraud detection to find out more information about how graph databases and Neo4j backed applications are great for helping you detect fraud quickly and investigate that fraud. Thanks for joining us.